Dear students, I am Santhan, working as a physics faculty in Target English Medium School. Today, in this Part-2 video, I would like to teach or explain about what is the relative density and some numericals, how we can find the relative density when they are given the density of a substance. But before going to that one, in the chapter of floating bodies, so in our previous video, so we are discussing about the concept about the density. What is the density? The mass per unit volume is called density. Its formula is D equals to mass upon volume. SI unit is kilogram per meter cube. CGS unit is grams per centimeter cube. And the 1 kilogram per meter cube is equals to 1 by 1000 gram per centimeter cube. 1 gram per centimeter cube or cubic centimeter is equals to 1000 kilogram per meter cube. That is the relation, that one. And first of all, in this time, before going to the relative density, we discussed about how we can find the density of the irregular shape of the object. How to find density of irregular shape of the object or body. So means generally, what is the formula of density? D is equals to mass upon volume. Mass upon volume. So M is the mass, V is the volume. But in case of regular shape of the bodies, mass is we find easily by using the physical balance or electronic weight balance or common balance. That's why. So the mass of the regular or irregular shape of the body we can find with help of the electronic weight balance. Regular shape means we know that cuboid, okay, sphere, cone, cylinder, this type of one is there. But irregular shape means, for example, fruit. So many vegetables, fruits, leaves, they have the which one different shape is there. They have not particular shape. That's why. Or stone also. These are the irregular shape of the bodies. But the given body is either regular or irregular. We can find its mass by using the physical balance or common balance or electronic weighting balance, anyone. So that's why for the mass no problem is there. But what about the value? In case of regular shape of the bodies, for them they have particular formulas are there. So volume of the cube, we know that L cube like this one or D cube. Volume of the cuboid, so means L into LBH formula, we know that. This is the value. Like the same 4 by 3 parallel sphere. Like that type of one is there. So that means for the regular shape of the bodies, we have one particular formula is there to find their volume. But so means mass is the common way to find either the body is irregular or regular by using the physical balance or common balance or electronic weighing balance. But the volume of the regular we can find by using a proper formulas. But in case of irregular shape of the bodies, is any formula is there to find the volume? No. That's why to find the density of the irregular shape of the object means mainly what you can find the volume of the irregular shape of the object. So mass is found by the electronic weighing balance or physical balance, and the volume is you can find our present method. Then finally we can find the density of the object. So it is a measuring cylinder. You know that when you see this object, you know in standard level it is called a measuring cylinder made up of the plastic or glass. So that's why what are the materials are required to perform or conduct this activity means mainly measuring jar or cylinder, measuring cylinder. Second one is a stone. It is an irregular shape of the object. Water. Fine thread. So these are the materials are required to find the volume of the irregular shape of the object during finding the density of irregular shape of the object. So listen. First of all, we can take an empty measuring cylinder. Empty measuring cylinder. Cylinder is filled with water up to 50 ml. That is, we are considered as the initial volume of the liquid in the measuring cylinder. That is noted as V1 ml. Next, now we can take a irregular shape of the object or a stone. The stone is tied with a fine thread. Here, the thread mass you are not considered because of it is a lightweight thread. Now we can take a stone. The stone is tied with thread in all sides, and slowly it is dipped into the water in a measuring jar completely, like this. Like irregular shape. So it is a stone. We know that when the stone is completely immersed in a water in a measuring jar or cylinder, so the level of the water will be slightly rises and reaches particular level. That level we can say as a V2 ml. For example, that is we can say as for understanding of 70 ml. So what is the difference in the volume of V2 and V1? That's why the volume of stone is equals to nothing but V, this is 1, is equals to V2 minus V1 into ml. Why? Because of means so when the stone is dipped completely into the water, the level of the water is increases and reaches to one particular value, that is the V2. V2 is the higher value than the V1. That's why V2 minus V1. So now we substitute these values. But during the examination, no need to mention these values. For understanding of you, in this time only, I can set these values. So V2 means 70, V1 is nothing but 50. So totally, what is that one? 20 ml is nothing but 20 centimeter cube. Why? Because of according to the floating bodies concept, 1 ml is equals to 1 centimeter cube. That is equals to 1 gram. So 1 milliliter is equals to 1 centimeter cube. That is equals to 1 gram. That's why 20 ml is nothing but 20 centimeter cube. That's why what is the volume of the stone? 20 centimeter cube. What is the formula of the density? Density is equals to mass upon volume. For example, the mass of the stone, just for understanding of you, the mass of the stone is 500 grams. Just we can say that. So means mass of the stone is 500 grams. And what is the volume of the stone we find here? 20. For example, here 400. So 20 centimeter cube. Now these two values are substituted here. D is equals to 400 upon 200 gram centimeter cube. Sorry, 20. 0 cancel. That's why D is equals to 20 gram per centimeter cube. Is nothing but what is the density of the stone? 20 grams per centimeter cube. It is not exact value, just for understanding of you only. That's why we know that already we are discussed very clearly in our previous video. When an object density is more than the water, it will be sink in water. The object density is lesser than the water, it will be float on water. So what is the density of the stone here? 20 is nothing but its density is more than the water or not. That's why it must be sink in the water. That is the way of the method. Once again listen, how to find density of irregular shape of the body. So first of all, we can take any irregular shape of the object like a stone. For example, stone. Measure its mass by using an electronic weighing balance or by using the physical balance and note its value. Next one. Now we can take an empty measuring cylinder. An empty measuring cylinder. It is filled with water up to particular level and noted as V1 ml. Now we can take the stone. The stone is tied with a fine thread and gently it will be immersed into the water without splash. Splash is nothing but come outside the water. So when slowly or gently it will be dipped or immersed into the water completely. At that time we know that the stone is occupied some volume inside the water. That volume of the water will be rises. Okay, so then the level of the water will be rises and so its volume we are noted as V2. Then the volume of the stone V equals to V2 minus V1 ml. So density is equals to, we know the formula, mass upon volume. Mass is already found, means mass and volume values both are substituted in that formula. You can get the density of which one? Irregular shape of the object. So are you understanding clearly? So it is very simply okay. Now I will explain the relative density. Simply we are written RD. R dot D means relative density. The ratio of the density of a substance to the density of water at 4 degrees Celsius is called relative density. So simply we can write RD is equals to density of substance upon density of water at 4 degrees Celsius. Listen very carefully. What is the relative density? So already in our previous video we will be discussing very clearly. With help of the water only, we can easily say that which objects are sink, which objects are float, means based on the density of the water only. That's why. So relative is nothing but we can explain the relation of the other liquid or other substance, that is either solid or liquid or gas substances with respect to the which one? Water. Water is the common factor with so with help of the water concept we can easily express the what is the density of the other substances. Is nothing but finally what is the relation between water and other substance, that is either solid or liquid or gas. That is the relative density. How to define the ratio of the density of a substance, that is either solid or liquid or gas, to the density of water at which temperature? Exactly 4 degrees Celsius is called relative density. So relative density equals density of substance upon density of water at 4 degrees Celsius. Why the water we are considering at 4 degrees Celsius? So we know that in previous class we are discussing that, means in 8th standard level, anomalous expansion of water. The water will have a special or peculiar behavior that is called anomalous expansion. What is that one means? From 0 to 4, it will be start the contraction instead of expansion. From 4 to 0, start the expansion instead of contraction. That's why. So means the water density is the maximum at which one? 4 degrees Celsius temperature. Due to what is that one? 1 gram per cc or 1000 kilogram per meter cube. That is the density of the water at 4 degrees Celsius. But at the remaining cases, density will be changes. Is nothing but lesser than at that 4 degrees Celsius. That's why relative density is equals to density of substance upon density of water at 4 degrees Celsius. It has no units. It has no units. Why? Because so relative density does not have any units. Why? Because density of substance, density of water. Substance, whatever the substance, what is considered the density. Density is a physical quantity. Substance is not a physical quantity. What is not a physical quantity? It is a substance. Density is a physical quantity. That's why, in the numerator and denominator, in both cases, you are observing that what is there? Only the same physical quantity. Here density physical quantity. Here also density physical quantity. That's why relative density has a pure ratio of the same similar physical quantities, or it has no units because it is the ratio of two similar physical quantities. So for example, relative density is equal to density of the substance in CJ system. We can say that. What is that one? Gram per centimeter cube. What is the density of water in the CJ system? Gram per centimeter cube. Units only. The density of the substance, units in the CJ unit, gram per centimeter cube. Density of water in the CJ system, gram per centimeter cube. Both can see. Then what is that one? No unit is nothing but not zero, no units. That's why relative density has no units because it is the ratio of two similar physical quantities. So in this part video, we discuss one numerical. About relative density. Numerical one. The density of an object. For example, aluminium. Instead of this one, simple I say that the density of aluminium is 2.7 gram per cc. Listen very carefully. The density of aluminium is 2.7 gram per cc. Find its relative density. Listen very carefully. The density of aluminium is 2.7 gram per cc. Find its relative density. That is it. So here, aluminium value they are given in which system? CGS system. Is it correct or not? So now come to that one. Relative density formula is equals to density of the substance. Here which substance? Aluminium. That's why Al upon density of water at which temperature 4 degrees Celsius. Okay, anyone. Then Rd is equals to, what is the density of aluminium? 2.7 upon, what is the density of water in CGS units? Already we know that 1 gram per cc. In SI unit 1000 kilogram per meter cube. That's why, so the density of water is 1. That value they are not given. That's why that value is constant. Due to that one, so density of the water in SI and CGS unit must be keep in your memory. Density of water in CGS unit is 1 gram per cc and SI unit is 1000 kilogram per meter cube. So that's why relative density of aluminium is 2.7. That's why. So the density of the aluminium is 2.7 gram per cc. At that time, what is its relative density? 2.7. This is the way of the method for 1 mark. Next, another second numerical. Also, one more numerical. We discuss that. The density of the copper is 8,900 kilogram per meter cube. Listen very carefully. The density of copper is 8,900 kilogram per meter cube. Find its relative density. So, in our first numerical, the value of aluminium, density of the value, they are given in CGS. Here, each system SI unit. That's why, which units of the system they are given the density value. Based on that one, you follow, substitute the values of density of water. Relative density is equals to density of copper. In the place of substance, what you can write? Copper upon density of water. So relative density is equals to density of the copper. What is the value given? 8,900 upon density of the water in SI unit 1000. Okay, 2 zeros, get cancelled. So relative density is equals to 89 upon 10. So relative density is equals to 8.9. Directly here also I write, but for understanding of you. That's why, what is the relative density of the copper? 8.9. Here you memorize that simply. Okay, what is the density of the substance in CGS unit? The value is also same as for which one? Relative density is nothing but density of the substance value in CGS and relative density of the same substance always the same. What is the CGS? What is the density of the copper in CGS unit? 8.9. Then relative density is also 8.9. In previous numerical, aluminum relative density is 2.7 in CGS. Sorry, density is 2.7. C grams per cc in CGS. Relative density is also 2.7. That's why from that one you can easily understand the density of any substance in CGS unit is same as the relative density. Thank you.